to present myself briefly, I am Muhammad Ali Al-Hatimi. This is my name is not written down correctly on the Zoom, but that's fine. So I am an agricultural engineer. I have specialized in organic agriculture, agroecology, and uh, Mediterranean agricultural systems. And I have co-founded a Moroccan platform that is called Nshfat, which means it dried up in Moroccan dialect, and that aims to well popularize topics around environmental topics in Morocco, and with a specific focus on climate change. And within my actual job and this Moroccan platform on climate change, we are also using a lot of satellite imagery. So I will share with you throughout the presentation some satellite imagery that can help you into getting into those environmental topics and issues. So I will share with you my screen. Okay. Um,
I don't know if anyone else can, but I can't see anything, just the black screen. Ah, there we go. Now I
ca-
can see.
okay, great, great. So I don't know how familiar you are with the Moroccan case. How many Moroccans are here and are familiar with the climate change issues in Morocco, the drought that Morocco is experiencing for 6 years now. Yes.
Um,
Nabil
um,
Himmish. This is clearly a Moroccan name.
yeah, so I'm quite aware, but mainly through the parliament, I would say, more than the physical manifestation of that crisis. I'm, I'm sensitive to how it's recaptured by the state as a propaganda object.
Exactly. Yeah. We'll get to like the political and governance issues around the drought in Morocco later in this presentation. But so this case study, I will try to explain to you very briefly the this water and climate crisis in Morocco, and I know that some of you are from other countries, but you can very easily make some parallels between the Moroccan case and the Lebanon case or any other countries, and that's it. Just to speak about this drought that Morocco has been experiencing for 6 years now. 6 years now. We had 6 years in a row of with precipitations that were 20 to 60% below the historical average. This year is still a year of drought considering this parameter, but it's been a year with significantly better precipitations than 2024. And here you can see the improvement, for example, in 2 months, and we could do the same comparison compared to the last year. So you can see here how these areas particularly the area, so on the coast, the area of Casablanca, El Jadida, etc., are much greener now than 2 months ago, or in March compared to January 2025. And I will share with you my screen to show you how can we use this tool, which is NASA World View. It's a very easy tool to use. Um, and you can use it for any area of your interest.
The screen sharing stopped. I don't know if that
Yes,
was on purpose.
I will share again my screen to share the total screen because I was sharing only the the presentation. Uh, so so to use this tool, so you go on NASA World View, very easy, and then you get to this site basically, and you have satellite observation that is relevant for like large areas, because if you zoom in, you don't have enough details uh, compared to other tools. Um, so just briefly to show you how can we make this kind of comparisons. uh, you take one area of your interest, here, northern Morocco, and you can choose a date. So, for example, let's see that here, for example, we are starting with the 5th of April 2025. So there is no significant difference with the 8th of April, but we want to compare with 1 year before. So uh, let's say the 8th of April 2024, and you will see that sometimes, well, mm, the climate is cloudy, etc. So you can just move to other days to find the right day, and you can observe these kinds of differences. So here again, what you can see is that this specific area here, so the area between basically Rabat and Essaouira was completely dry by that period last year, and now it's much greener. So this is a very basic tool to observe such things, and maybe if some of you want to try something right now to observe one area between two different periods of time, we can do it right now just to show you. Lebanon, Tunisia, I don't know. Otherwise, we can move on into our presentation. Okay, let's move on then. So basically, that was just to show that in Morocco, this drought situation that is ongoing for 6 years now is uh, being less destructive than 1 year ago. However, you can here observe other types of tools to see drought conditions or non-drought conditions. So this is a tool from the European Drought Observatory that covers the whole Mediterranean, and that is quite relevant to see, well, are we in a certain territory in a situation of drought or not? Because drought is not defined only by rainfall at a certain point of time. So, for example, in Morocco, we've had a month of March and April 2025 that were far above the historical average. But that does not mean that the country is not in a situation of drought anymore, because we've had these months of significantly important rainfall, because drought is defined by uh, different parameters of humidity, of different layers of soil, of rainfall at different points in time, etc. So you have this tool that show you month by month in a certain territory if you are in stage of vigilance, of warning, of alert, etc. And I can again share with you my screen to show you this tool that is quite interesting, and you will see that you can, well, check for any area of the Mediterranean. Unfortunately, you cannot go much below. So, for example, in Morocco, it stops on the Rabi basin, but you cannot go to the area of Tansif, Sousse, etc. Same thing if you go to, for example, the Arabian Peninsula, you have only the Levant area, Iraq, Syria, etc., but you don't have the remaining parts. But it's still an interesting tool, and you can so you have a tool that is very easy to use. You can change the year, the months, and you can see the evolution of these drought situations. So in the case of the Arab world, let's say you have two major areas in a significant situation of drought, so Morocco and Western Algeria, and you have this area in the Levant, so Palestine, Lebanon, Syria, Iraq, that are in a significant situation of drought. So you can use this tool. This is the main parameter I can use, but you can also use other ones such as, well, precipitations to see for some specific months if you are above or below the averages, etc. If you have any questions, don't hesitate. Well, and now let's go beyond the recent months, and here you will be able to probably draw more parallels between Morocco and the other areas that you know best. So when we speak about drought, we don't speak only about or aridity. We don't speak only about the rainfall on some specific months. We also speak about the availability of water and the pressure on the water resources in a certain territory. And here the topic I will present now is common to almost all the countries of the Arab world. It's a significant drop in the water availability per year per capita. Just to show that drought has become structural in Morocco, that we are not in the same situation of water availability abundance as in the 60s. This graph shows basically the amount of annual fresh water, so basically the amount of rainfall on the country that is divided by the population. So basically in Morocco we have about 14 billion cubic meters of rainfall per year, divided by the 37 million inhabitants. And the challenge that we are encountering in Morocco is that, well, this amount that is imperfect to define what is the level of pressure on the water resource, but that still gives us quite a good a good overview, is dropping very fast in Morocco. So you can see that in the 60s it was above 2,000 cubic meters, and now it's below 500 or 600 cubic meters per year per capita. While we define that the extreme water stress is for countries being below 1,000 cubic meters per year per capita. And this is almost the case for all the Arab countries, maybe with the exception of Lebanon, Syria, Iraq, and Egypt that are either in good climate conditions for Lebanon, for example, that has significantly superior precipitations than the rest of the region, or that receive significant water flow from rivers like the Nile or the Euphrates or other rivers that are coming from Anatolia, for example. But all the Arab countries are in this current situation of extreme water stress below 1,000 cubic meters per year per capita. And this is linked to first population growth. So, for example, for Morocco, threefold increase since the 60s. So we went from 12 million inhabitants in 1960 to 37 now. So this very obviously divides the same rainfall three times, and also climate change. So, for example, in Morocco, we can see a decrease in rainfall of 10 to 40%, depending on the region, which also decreases the global rainfall on the country. So we went in the 60s from 20 billion cubic meters per year for the whole country to 14 now. So you can see that eventually for the country, we have a division by 4 of the available resource per capita. So drought has become something structural and not just depending on the rainfall. We are in a situation of stress. And if you see, for example, countries like Iraq, you will see that, well, the demographic growth is much superior to the one of Morocco. So you have a growth that is not threefold, that is significantly more, plus a significant decrease in the water flow from the rivers coming from Anatolia, which also brings a superior vulnerability to regarding the water resource. Other physical factors that are intensifying the water crisis. So this is an example for Morocco. We have at Nishfat modeled the temperature increase, the observed temperature increase since the 60s in different regions of the country. So this is for the region of Fas Meknas, that is an agricultural cradle of the country, that is an amazing region in terms of agricultural production. And you can see that, well, the temperature, so the seasonal temperature, has increased since the 60s by 1.3 degrees for winter and 2.8 degrees for summer. So for the ones interested in the Moroccan case, you can check this on our website. So I will just try to show you quickly. So on our website, we have this section resources, average seasonal temperatures, and you can go well, region by region. So for example, if we go to Gelmim Wadnoun in the southern part, you see the same tendencies. So from basically 22 degrees, 22.5 degrees to 23.5. So also an increase in temperature for summer, for winter, etc. So this is we made this using Copernicus climate change database. So this required a bit of coding, etc. So if you are interested in that, I can share with you some insights later, but it's much complicated to get into those kinds of tools. And for today, I will just present to you some tools that are easy to use without any coding. So why is this challenging? Also because basically when you have a higher temperature, you have higher evaporation rates. So higher evaporation for the rivers, for the water reservoirs, dams, etc., which puts more pressure on the water resource, and which also puts more pressure on, well, cities, heat waves, thermal comfort, etc., but also on the ecosystems and the agricultural sector, because as you have a higher temperature, the water needs of your agricultural systems or ecosystems in the 2020s are much higher than in the 60s because you have a higher temperature, so higher evaporation needs, and you need to give more water to your ecosystem to maintain the same quality of ecosystem, which means that, for example, an olive orchard in the area of Fas Meknès that was non-irrigated in the 60s needs to be irrigated now because, well, otherwise it will not give any yield or not the same yield. So to reach the same performance, you need to irrigate instead of non-irrigating in the 60s. Other elements to show that, well, there are physical factors that amplify this topic of drought, of water stress, etc. I'm insisting on water stress because it's basically the thing that we have in common in all our countries. But you can see, for example, that in Morocco we had several heat waves where when we surpassed the 50 degrees, which never happened before 2023. So one in Agadir, one other one in the area of Tata last year. Also, winter heat waves, which was not very common before, and now we are having also we are breaking temperature records also in winter, which also puts significant pressure on the water reservoirs, on the ecosystems, on the agricultural systems. And this decline in water resources could become even much uh, significant in the next few decades, as well, depending on the countries, obviously. But the IPCC projections are giving us some insights about how could the rainfall evolve in the different areas of the world. Of course, these projections in terms of rainfall are less reliable than the ones on temperature that are very, very reliable. These ones, there is a certain level of confidence, and we can already see some tendencies, but are less reliable than the ones on temperature. But you can see here then that Morocco and generally North Africa will probably see a significant decrease in rainfall. Same thing for the Mediterranean, so for the Levant, for Anatolia, etc. Probably in the area of Sudan, Chad, the Arabian Peninsula, we would see an increase in the rainfall, but uh, it's hard to say that it will compensate or no the effect of the increase in temperatures. So that does not mean that the Arabian Peninsula will be a green paradise in 15 years. But it's just to show you some tendencies of what we know for now. Then, so the impact of all of what I have shown before. So some years that are really with the scarce water rainfall, plus an increase in temperature, plus significant heat waves that increase water evaporation. And you can see here the evolution of the second largest dam of Morocco in the recent years. So you can see how this is absolutely huge. And for this kind of comparison, you could even use Google Earth or NASA World View to get some images and follow up the evolution of such an area. But you can see how huge this is, and we are speaking of the second largest dam of the country, with a capacity that is that reaches about 2 billion cubic meters. So about 10% of the annual rainfall of Morocco could be stored in such a reservoir. So we are, and all the neighboring area suffered a lot because, well, many areas that were depending for irrigation on that dam, etc. So thousands of hectares of citrus trees, olive trees that dried up because of this. Next, so I have spoken a lot about the crisis of offer, so how we have a decrease in water, in rainfall, and increase in temperatures that are putting more pressure on the water resource. But and this is actually the let's say the public discourse that is broadcasting the water crisis only as a crisis of offer of the water availability. Actually, it is much more than that. And here you can again draw a parallel with other countries. So I know that in Tunisia is the same case, in Palestine is the same case, in Syria, in many countries is the same case. There is also a crisis of demand, which means that before we were only, so this is the blue line, we were only using water for irrigation from superficial water, so from the reservoirs and dams, which means that we were using water that was 100% renewable. Basically, we are using the in 2024 the water that was stored in 2023 to irrigate certain area of land. So that kind of irrigation with superficial water that can be either modern through big water reservoirs and dams, or quite traditional using the superficial groundwater, like in the system of the Ghattara in southern Morocco, is quite a renewable model of irrigation. We could speak about the negative points around dams for biodiversity, for well, land grabbing, etc. But this is another topic. But the main challenge actually in the recent decades in Morocco is that this water crisis was mostly driven by the groundwater demand, and the most of the agricultural growth was enabled by the increase in groundwater extraction. We went basically from less than 200,000 hectares irrigated by groundwater to more than 800,000 hectares irrigated by groundwater. And we have put an increasing pressure on groundwater, which means that there is a certain level of renewable use of groundwater, because the water infiltration from well, from rain, from snow, etc. There is a certain level of water that infiltrates the groundwater every year. We consider that it reaches 4 billion cubic meters per year in Morocco. And then if we were using exactly those 4 billion cubic meters, we would be using only renewable groundwater. The challenge is that increasing as we did the use of the extraction of groundwater, we are not pumping 4 billion cubic meters, we are pumping 7 billion cubic meters, which means that 3 billion cubic meters are fossil water that was stored thousands of years ago, and that threatens the viability of that irrigation, the viability of, well, water availability in the next few years. And just to show you how there was a significant increase in the water in the groundwater extraction. So this is a comparison by well, Google Earth, of a certain area, Boudnib, in south east Morocco. You can see here in 2005 this area, this green big dot, that is the historical area of the oasis that was irrigated by a traditional irrigation system using superficial renewable groundwater. And here, when you see the 2025 map, you can see many small blue dots on the map. Can you see them? Dozens of them.
Yes, we can see them.
Those are water basins to extract groundwater during winter from significant depths to be able to irrigate the maximum possible area during summertime when the water demand of the agricultural system is huge. And you can also see that the historical area of the oasis, so this green dot, is getting a bit drier now because these monocultures of date palms are extracting too much groundwater and therefore decreasing the level of groundwater for the oasis that was getting that water from 5, 10, 15 meters beneath the soil, while the other ones, these new monocultures, are getting it from 100 to 200 meters. Yes, Munia.
Can you tell us a bit more about fossil water? What do you mean by that?
Fossil water, basically you have different layers of groundwater. You have certain levels of groundwater that are 100% renewable, which means that, for example, in this area I am presenting, the water that you would get at 5 or 10 meters is 100% renewable. It's the water that is stored from the recent rainfalls from the recent years. And if you extract all of it, you will have no more water available. And if you go deeper, you have certain geological layers that are fed by that renewable annual rainfall infiltration, plus a certain quantity of water that was stored 10 years ago, 100 years ago, 1000 years ago. And it depends on the layer. It means that some layers and some groundwaters can be fossil water of 100 years, others of thousands of years. And typically, when you go to Algeria, Tunisia, and Libya, you have one huge groundwater that is called the Albian aquifer that gathers 50,000 billion cubic meters of water, which is the equivalent of 2,000 years of rainfall for Algeria, which means that, well, that water was stored in thousands and thousands of years, and depending on the area, we can identify, well, that water was stored at some specific period of time, etc. But this is more technical.
And
just to say that.
Yeah, sorry. No, I just wanted to ask if, like, does the quality of the water differ the older it is? Like, how is it different if you're taking water of 1,000 years?
It can be of a good quality. It depends on the area. It depends on the geological layer it is stored in. But you can, for example, if you get your water at 800 meters or 1,000 meters, which is the case in some areas of Libya and Algeria and Tunisia, you could get water that is first hot because you are getting also geothermal energy with that water. And therefore, you need, before irrigating or using it, you need to let it cool down. Another thing that you could have, and this depends a lot on the geological layer, it's the salinity of water and the concentration in other types of minerals such as calcium, such as magnesium, etc., that are not always suitable for irrigation or not for all the crops. So you have some kind of adaptation of the crops that are used. For example, in some areas with the high salinity, they would uh, go more for palm trees or pomegranate, or for some seasonal crops, and use, for example, some portion of land for 3 years and then abandon it completely because it's been too salinized. So you have different agricultural dynamics and strategies to use those qualities of water, but even a fossil water can be of a good quality. It depends on the geological layer.
Thanks.
So thank you for the question. Then, so this is just a small slide to show you basically that, in our pursue of water economy in Morocco, and this is the case for many other countries. I know that in Tunisia it's the same case, for example. Our agriculture policy invested a lot of money in drip irrigation, to say that we will increase the irrigated areas, but no worries, we will use a water saving technique that will enable us to irrigate the same amount of water but for a greater area. Just to show you that, so this is an observation, an empirical observation of onion plots in northern Morocco, comparing in red the water needs of the plant and the actual irrigation with drip irrigation for 30 farmers. And you can see that actually they were irrigating twice or thrice the required amount for the plant, which means that actually even with this technique, if you don't have technical support for the farmers, if you don't have technical trainings, and if you have also a very cheap cost of water, you will have no interest into no first technical background and no interest, financial interest, into saving water and bridging the gap between the red and the blue lines. But this slide was just a parenthesis, but just to tell you that, well, those technical innovations have their limits without technical and financial support to the farmers. And I'm speaking about agriculture because in Morocco it represents 80 to 90% of the amount of water consumed in the country. Also, another thing, I will go very quickly on this one, but when we have a cheaper and easier access to water, agricultural systems change. And so, for example, in Morocco, we went from traditional agroforestry systems with the low density of olive trees to, for example, 300 olive trees per hectare, to modern systems with 1,000 to 1,500 trees per system, and therefore with a higher evapotranspiration rate, and therefore we need more water to irrigate a plot with what is known as a water saving crop, or an adapted crop to our climates, which is the olive tree. But depending on how it is cropped, it can be also a water consuming crop, and it can play on the water dynamics. The consequence of that, I was telling you that we are overexploiting those groundwater 3 to 4 billion cubic meters per year, which correspond to the biggest river we have in Morocco, the Sbou River. And last slide before going to, showing you more satellite imagery. So the World Bank in 2023 drafted a report on the water crisis in Morocco, insisting that investing only on new water infrastructure is not sustainable, both financially and environmentally. This is speaking about investing only on dams, only on desalination plants, etc., while forgetting completely about governance, governing those water systems, defining what is the maximum allowed groundwater extraction, what are the crops that we will be able to crop or not, regarding or climate or climate or water limitations, etc. Now, I will just show, I will briefly show you Google Earth and how to use it to see some agricultural, water, territorial dynamics. So first thing, I will show you how to get to this comparison that we have seen of Budnib, this area with many more monocultures of date palm now. So here you can see the current. This is very easy to use. You download Google Earth Pro, it's free, and you can dive in any area that is of your interest. And you can see that here, this is the historical oasis. So you can see how dry it is getting now in 2022. And here you can see all of those modern subsidized, state subsidized agricultural systems with big water basins that get water from the groundwater, from deep groundwater. So you can zoom with a very high quality, and you can also check on the generally palm trees monoculture. So for your information, palm tree is very suitable for oasis systems that are in complex agroforestry systems. So you have the palm tree with olive trees, with pomegranate trees, with the cereals, etc. But if you cultivate it as a monoculture, it will consume as much as an avocado tree. Because it's actually a tropical tree. The date palm tree is a tropical tree, so it consumes basically 1,000, at least for this variety here that we are cropping in southeast Morocco, 18,000 cubic meters of water per hectare, which is basically 18 times the rainfall of this area. So basically, the palm tree will receive 100 millimeters of rainfall, and we will complement it with 1,700 millimeters from the groundwater. So it is absolutely huge, and it is very questionable to expand the palm trees areas without controlling the groundwater exploitation, etc. So you can see that you have huge areas like this. You can even here measure some the areas um, of those agricultural lands. So let us try here, just for one single farm. You can see that this single farm is covering 4.5 square kilometers, which means 450 hectares, which is 450 times the average area of a smallholder in the area. Well, but generally, you can see that you have many blue dots in all the area, and you can also, through this tool, so this archive tool, check how the area evolved in the recent years. And if we go back to, let's say, 2005, you see that there is no blue dot beyond the oasis. So this is a very easy tool to see, well, the territorial dynamics, extraction of resources that are putting those local communities in danger, etc. And whenever you hear of maybe an environmental scandal or something like that, you can sometimes use satellite imagery to, well, see how that can be seen actually uh, from from very, very far. I will show you also a place in Algeria, another one in Morocco, and then we'll be done. But this is another area. So in Morocco, Tifelt. So we can see the area in 2004. This is an area with quite an interesting climate, 500 millimeters of water, 600 millimeters of water, so as much as in Paris, for example, or other quite humid areas, but that is not suited for crops that are using 1,600 millimeters of water. So, and you will see why I'm saying that. So you see here that, for example, you have this area that was not existing before, that was planted probably early 2000s or late 2000s. In 2006, you see that these were wheat uh, plots, and progressively we have now a huge avocado orchard. So basically, to identify which crop it is, you need to be a professional uh, cartography scientist, but you can cross-check with the what you can find on the media on well, there is a big dynamic of avocado in the area, etc. So and same thing, we can measure the area of this farm, and we have basically a 30 hectares uh, area that is dedicated to avocado trees with an irrigation of 1,000 cubic meters per hectare. So 30 hectares, so you have 300,000 cubic meters used for the irrigation of this single area, while Moroccan family will use maybe 80 cubic meters per year. So this just shows you the scale of water consumption in or overconsumption in the area. And then you can go to other areas. I know that, for example, this area of Luad is interesting. You see from very far. So let's go from very far. You can already see a small gray area here. And if we zoom in, you will see how amazing this is. This is groundwater extraction from what I was describing as the Albion groundwater. That is a huge groundwater that is significantly used in Algeria. And you have a big territory that is dedicated to uh, cereal production, potato production, palm tree production through the extraction of this groundwater, but with the significant challenge that is flooding the area. Actually, this probably, if we go back to 20 years before, I don't know if we have a good quality before. Well, you can see that in 85, this area was not a lake. This area was a desert, and progressively it became, we have this big flooded area because we have extracted so much water from the groundwater that the renewable groundwater is completely saturated and went from level of -5 meters of beneath the soil to 0 meters, and you have a significant challenge also of humidity for constructions, etc. So this is very documented, this area of Lued, and it is an exceptional study case. And all of those areas are traditional oasis systems that are now flooded. but that were before, so that were before only palm trees. But now you can see that you have water that is getting inside those depressions that were traditional oasis systems, a very smart system, one of the most incredible oasis systems that you can find. But you can see also those kind of dynamics. So these traditional agroecological systems that are replaced by those systems here, and you can see that you already had some of that industrial agriculture in 2007, but less than now. You have an extension of those industrial agricultural systems. That's it on my side. I hope that, well, this is useful. Just three very easy tools: Google Earth Pro, the European Observatory of Drought, and NASA Worldview to compare different things. And if you have questions, I'm here to answer.